Hello, I'm back. It's really getting difficult to keep track of all the stacks of comments and ideas that I've written down somewhere, and I can't find where they are. But anyway, I did want to look at the bar again because it seems to me that resonance is coming into play and probably grounding. And there might be many different ways to do it. The bar might not even need to be built if it resonates anyway with the other components. So again, if you look at that bar, that is not just machine marks. And if you look at the end, it really looks like they have put layers in there. Now, whether that's just on the end or if it's in there also, but then put a little thin tube of something around it. So I don't know if that's true or not, but that's what it looks like to me. And you can get other materials to resonate also. They don't have to be made out of silver. Silver might be better and it might aid in more efficient resonating, but there are some other ways too that I believe it could be built into the bar or it could be caused to happen. But you'd have to do some engineering on a bar. And I have some ideas that I'd like to pass on. And so, one of the things I came across, someone helped me come across it, is a magnetron. And the way I looked at it is that it's actually a capacitor in a way. And there are materials, many different ways to do it. Magnetrons are usually really high voltage, but I think you can do it in other ways too, because I'm going to just put these things on here so that you can look at them, and if you're interested, you can print them. So there you see that one. But what you would do is this would be the diameter of the bar. And so if you had small wafers of copper, and in this case it was copper, and then you had a cathode in the middle, and you had it coated with some kind of a coating that emits electrons. And one of the coatings that I've heard is fluorine is used in really, really high voltage capacitors. And so it has, what I've been told, 7 electrons and always looking for an 8th electron. And so what happens is somehow this is excited and it begins to emit electrons in these cavities. They call them resonant cavities that are surrounding this wafer. And it would be a little machining, but and you'd have to put them together, and there's some other things that you'd probably have to do. But what they do is it creates 12 or however many, I think you can go up to, it depends on your machining. You can go up to, I heard 32, but 12 is usually the number that they use. And the electrons are emitted out into this, and if you're, and they call them resonant cavities. So if you have resonant circuits that are going in the same direction as the cathode, and again, I don't know how to build, I'm not sure how to build this. This is an idea that I have, and I'm not sure how you would get it to resonate, but there's something I still believe in this. There's something in there, probably the coils or the amount of flux that is in there that somehow you would have to force this to that frequency. It would be resonant to that other frequency. And then I'm not sure how you would gather it, but it is, better than nothing if we're looking at how we could possibly do it. And this will give other people ideas into, how it might be done. But let's see what I've got here. So this again is how it might be done. You'd have a circle, a tubing. You'd have the little cavities, resonant cavities. You'd have what they call an emitter area or an interaction area, excuse me. And you put it all together somehow, and that's for a lot of people to try and figure out, including myself. But you hopefully can gain resonance. You can put it into the bar. You can actually build it in there. But I think grounding is going to come into play also. Let me show this for you. Okay, and also on here is a link where you can go and read about this magnetron radar. So, and here's some other things. I also got something from someone that was talking about cobalt. Basalt, and they were talking about, that's on the other one. They were talking about powdered magnets, because when you break up a magnet into powder or little pieces, they still retain their polarity. And you put them all together and they will, if you have a powder, you could put it in a liquid and it could circulate by magnetic flux. And if you have something in the middle like copper, and then you also have some coils in there, you could probably generate some more current. And then even on the outside, you could have a coil that goes all the way across, and you could make it into a bar. So lots of different possibilities. Let me give you a shot at that. Something to experiment with. And other possibilities of coil, configuration. And then also, this was interesting. They did a video on the charging of a cell phone. And I believe that it's possible to have a coil like they call the perpetual motion device. They call it that, even though it's not perpetual motion. But could you trap current or current in there between magnets, and then have a battery that runs the coil rechargeable? And so if it creates the current and the flux, all that, and you could have possibly something circulating around. There's another video about a guy who is working on something like this, and you could induce that into another closed circuit, possibly. So here, let me give you this. I can't go too much longer there. And then also I wanted to show you possible ways of tuning it. And this is in that radar tutorial, where you put coils into the cavity areas, and then on the end here you have, in the right angle direction, you've got a coil that could be excited and that could introduce current into, these are called single wall, I think they call them single wall coil. A copper tubing would be like a coil. So you can go ahead and look at that, and I'm going to go ahead and give you a shot of it. And I've only got a couple more minutes here, but I want to show you what we're up to, what I'm up to. And I'm getting a lot of advice from a lot of people. But putting a magnet, the same set of magnets in the stator. This is a stator. These are the coils that go on, that are in there on the side. The other coils go that way, these go this way. And so what you do is you locate these pairs equidistant in the coil, equidistant from there to there and there to there. And so And exactly what's going to happen to those magnets inside a rotating field, I'm not sure. I tested it. I actually put these, this is kind of like what it would look like, but it would be on a bar, and roughly the distance. And so you get it on the bar, and you locate the bar in the middle and equidistant from the transformers. And I'm going to give you a shot of this because this explains theoretically how it might work. And there's a little engineering there, and that I did this so you could see that this is like my bar that I have, where it fits between in the hole of the magnets and then meets this in the center, and it's a spacer. And if you have to adjust it, you have these, you could have varying, this is like a huge washer. If you had, you know, if it needed to be 1/2 inch less or something, or 1/2 inch more, you could add 1/8 inch on each side, or you could create a whole new spacer. But that, I built that bar, and this kind of shows you also what it would look like, you know, without a lot of details. Let me give you a better shot of that, just to give you a better shot. And so this is what is being proposed, and I've got a little bit of work to do. I do have that bar that I was talking about. I had it made, and you can actually turn these things onto the transformer and then slide the bar in. And I put those little things on again to center it, you know, more exact in the stator. And this, I realized now that I was off about 1/8 of an inch, and so I would have these rebuilt again, built again. So this will give you an idea of what I'm thinking, and what has been proposed by a lot of different things, and I've kind of taken from here, taken from there. But anyway, I've got to stop now. So give me a holler. Let me know what you're thinking about this, and I will talk to you soon, okay? Thanks a lot.